then your own part is with extra time in the committed. But then you cannot follow. You should use public holiday only because play silent. Like nice time for yourself.
What's the end of it in another day?
Independent day. This is one day independent.
That one whole lecture off. But the questions are set. Okay, so like I said, at some point I will need to search for the exam. If I catch you, when you graduate, you have this kind of attitude. And you need Jesus. Slide number 40. So I showed you the two. Have you printed your wallpaper? Classes behind. Okay, so anyway, I print. Evaluation is the primary reaction indicated by CYP. Have you gotten your medicinal chemistry textbook now? Beautiful. So have you taken time to study that chapter on drug metabolism? So like I told you, certain questions, 50% of the questions will come from there. Where if you go out the textbook, it's not very likely you will pass. So you have the homogeneous materials conjugated to it that will further is to step out from the okay. So when we say here that hypertension can be followed by non-CYP450 reaction. So phase 2 is you don't find CYP450 involved in phase 2. They're going to be seeing enzymes like glucoronidase, phosphatases, N-acetyltransferases, transferases, all of that. Okay. The enzymes in phase 2 are transfer enzymes.
Transparency.
So the same way I told you that a clue when you see words that end with aces, they are enzymes, biological enzymes. Lipases, they are enzymes specific for enzymatic reactions involving lipids. Esterases, they act on esters. Amidases, they act on amides. Hydrolases, they act on hydrogen. Dehydrogenases, we remove hydrogen. So from their name, you can tell the kind of reaction that they catalyze. But then the peculiar thing about the CYP450 enzymes is that they are known as mixed function oxidases. So they are not functional group specific. It's mixed function. So that when you look at peculiar drug metabolizing enzymes, you get familiar with 2D6, 2C8, 2C9, 2C19, 1A2, 3A4, 3A5. So that would be now the compound. So these are the major you find here much about that. You need to read and study when you come across them. So those are phase 1. Okay? They are under the mixed function. So you will find drugs of differing functional group. Their chemistry, there's nothing unique about their chemistry that will be suspect. Okay? So 2C919, for example, I think that's where you find dopamine, omeprazole, thank you very much. 2C9 warfarin, 2D6 codeine, dextromethorphan, etc., like that. Okay? 3A4, that's over by catalyzes a whole lot of a bigger fraction of prescription medicine. So there's no unique chemistry about their subject because they're just mixed functional substances. Okay, so that's it. But when you now hear of glutathione S transferase, that's a phase 2. Are you with me? Glucuronidase, what do you know for UGT, uridine glycol, uridine transferase. Once you are hearing transferase, it speaks of phase 2. So you know that these enzymes will actually be conjugating an indigenous material to our drug and then the drug is activated. So hydroxylation of the carbon alpha to heteroatoms often lead to cleavage of the carbon heteroatom bond, as seen especially with nitrogen oxygen bond. So as we're looking at this drug metabolism, we're considering 4 centers. We call them carbon center, nitrogen center, oxygen center, sulfur center. And of course, these heteroatoms don't stand alone. They will get bonded to a carbon. Okay, so you will have carbon, nitrogen, carbon, oxygen, carbon, sulfur. So we'll appreciate that when we get there. They don't stand alone. You will not find nitrogen just it will be bonded to a carbon. Oxygen bonded to carbon. So that you will be able to appreciate that statement that hydrogenation of the carbon alpha to heteroatoms often lead to cleavage of the carbon atom bond, seen especially with this. So it is important, very, very important, that there is an available hydrogen on the atom that gets hydroxylated. Very, very key. That whatever atom is getting hydroxylated has a free hydrogen. There is no bond there. We're going to see rules that guide the drug metabolism. But just have that in mind. That's our thing. Yes, it's in the team. You have them. Oh, there's no kappa inside. I'm a 500 level. You mean you cannot be too sure not to go and buy your stuff?
We have now.
And I want. What did he say? You are not too sure. You are
Activity. How are you doing?
whenever they see you, they should know that you are the pushers of all. You don't have any systems. Okay, so we want to look at aromatic hydroxylation. We're looking at phase 1. We will have carbon center, nitrogen,
This is the easiest
oxygen,
one.
sulfur center.
This is the easiest
Under
one.
carbon center, you have
Is this fountain cake?
I'm saying, you see,
what's simply
For this course.
once you
all
have
the
an
fountain we're
aromatic
doing, this is the easiest ever.
you represent hydroxylation by this sign, oxygen, a bracket, square bracket. So once you have it, you will have generation of an intermediate.
What comes up?
Okay, that's what you will see in your slide. You have generation of an intermediate arene oxide. So you have generation of an intermediate arene oxide. Arene oxides are not stable. I'm going to come across arene oxide, yeah, I'm going to come across the oxides. Okay, so generation of an arene oxide are not stable. They usually break down. Now, what they now break down into is dependent on the enzyme that is available in that environment. And that's what that slide is showing us. So if you look at it, I will be on slide 50 now. So if you look at it, if, oh sorry, it's slide before 50. So this can, if there are no enzymes in the spontaneously break down to what do you have? No. I need to think of this to space. So spontaneously, it breaks down to a phenol. However, if you have epoxide hydrogens in its environment, what does it break down to? You are following me. Look at your slide. What does it break down to? 1,2 diethyl and 1,2. Okay? So that's the aromatic functional group there. Now, if you don't have spontaneous breaking down to phenol, you don't have epoxide hydroxylase or hydrolase there, but you have glutathione. Glutathione is a phase 2 metabolic enzyme. Okay? It's actually a tripeptide. You see that when you get to phase 2. Tripeptide involving cysteine. What else? Further enzyme. You know them. Get them. So cysteine, glycine, glutamic. But the key component of glutathione is cysteine because cysteine has a thiol functional message. Okay? So if glutathione is in the environment, then this your spontaneous phenol that was generated will now some horrible ways, but these students were writing structures in first semester. Yes, sir. Hydrolase, hydroxylase, so what you will have is that if glutathione is here in the environment, glutathione is a reactive oxygen species scavenger. They are endogenous antioxidants that you have. So if you have it in the environment, I put glutathione here, then this is what happens. So it will bind to your phenol that will be generated spontaneously. Just bind it and then like that. And if none of this is around, but you have, because you always have micromolecules. Your protein, micromolecules. Because this becomes a reactive oxygen species. Okay? So if you don't have spontaneous breaking down of phenol, you don't have epoxide hydroxylase in the environment, you don't have glutathione as a reactive oxygen scavenger, then this your phenol will bind to macromolecules, and that can induce adverse drug. So what you find here, when your spontaneous phenol is not binding to macromolecules, this can all have things. So it generates adverse drug. Okay, so that's what can happen, and all of this is on. So whenever you see an aromatic nucleus that doesn't have an electron withdrawing group as one of its substituents, the aromatic nucleus it deactivates the aromatic nucleus, and it's not likely to have it. But if you have an electron donating group, it activates the ring, and then it can direct this reaction to happen, and any of it can happen. So I could ask the question, or I could give you a molecule that contains an aromatic nucleus, and I say profile likely metabolites is one metabolite. Okay? Sorry, hold on. Function oxidation of so arenols via an epoxide intermediate, which is your arenoxide, based on your metabolism for drugs with phenyl primarily at the para position. Okay? Activated rings, that is those with electron-rich subsequent, are more susceptible, while those which are deactivated are generally slow and resistant. So I can give you a drug molecule that contains an electron between subsequent. Then I tell you, profile likelihood, the likelihood of go and give you this. When it has an electron between subsequent, you use mass. To tell me that it's not likely to occur, or if it will occur, it will be very slow. Why?